there is another form of a parabola. This is called vertex form. And the reason is, it's very clear to see in the equation itself where the vertex is. Remember, the vertex is denoted by the letters H and K. There are three parameters here. There's A, H, and K, and each control the appearance of the parabola in different ways. We're going to take that generic form of the parabola and we're going to plug it into Desmos, see the effect, and then we'll write a quick summary. Now, all right, let's look at our first parameter, A. What did you see? What did you notice? Well, for one thing, when A is positive, the parabola opens up like a happy face. Positive A, negative A, positive A, negative A. Another thing we notice is that as A gets farther and farther away from 0, the graph gets narrower. So here we are very close to 0, it's wide. We go farther from 0, it gets narrower. On the other side, even though it's facing down, we're close to 0, we're wide. We're far from 0, we're narrow. If we were actually on 0, it ceases to be a parabola anymore, it becomes a straight line. So that's what A does. Let's look at H. So H controls the horizontal position of the parabola. Now I want you to notice that in the formula it does say x minus h. Why doesn't it say x plus h? Well, the reason is when we move this slider to the right, the parabola goes to the right. When we move the slider to the left, the parabola goes to the left. If we had a plus sign here, with a plus sign, everything works backward. So what we've got to remember is where it says x and then a number, that the h is actually the opposite of the number that we're going to be seeing. Now finally, let's look at the effect of the k slider. Surprised? It really shouldn't be. As k gets bigger, goes up. As k gets smaller, goes down. K is 0, or right on the axis, right on the x-axis. So these three parameters mean that I can determine where I want a parabola to be and the shape of it. So the A is the shape as A gets farther from 0, the graph gets narrower. As A gets close to 0, the graph is wider. If A is positive, if it's greater than 0, the graph is a happy face, this. But if A is less than 0, the graph is sad. Now what about H? This is the horizontal. You know, just like the horizon goes left to right, horizontal is a left to right control. And when we look at the equation, we're going to look for the opposite to x minus h. Okay, and then finally, k, this is the vertical up and down. It's like when you jump, you have a vertical leap. Whatever number you see at the end, that's how far up you're going to move the parabola. So let's look at a few examples. Graph y equals and then x minus 2 in parentheses squared plus 4. I'm going to look at x minus 2. I look at the minus 2, but then I realize that the h value is actually positive 2. It's the opposite of what you see. So the vertex is at 2. The number at the end, 4, you can trust that. If it's 4, that means that's 4 in the vertex. So 2, 4 is the location of the vertex. Does it open up or down? It opens up because the a value is positive 1. You don't see a, but it's positive 1. Now let me tell you a little shortcut about plotting parabolas, especially when the a value is 1. If I do 1 times 1, that's 1. Actually, let's start with 0. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Then 25, 36. That's enough to prove our point. Now look at how far it is between the numbers. From 0 to 1 is a jump of 1. From 1 to 4 is a jump of 3. From 4 to 9 is a jump of 5. And there's 7. And there's 9. Etc. It keeps getting bigger and bigger by odd numbers. Well, this does translate to the graph. Here's how it does. If you found the vertex, the next point is up 1 and over 1, then up 3 and over 1, up 5 and over 1, 7 and over 1, 1, 3, 5. On the other side, up 1.
On the other side, we can reflect the same structure. So starting at the point 2, 4, we'll go up 1 and over 1 on both sides of the axis of symmetry, and then finally up 3 and over 1. Connect them with a smooth curve. In the next example, it says x plus 3, but we're not going to go right 3 with the vertex. We're going to go the opposite. So we'll go to the point -3, -1, put a dot. What direction does the parabola go? Because of the negative out in front, a equals -1. The parabola will open downward. Down 1 over 1 and down 3 over 1. We do this and we'll have 5 points. Connect them with a nice smooth curve. We'll do the skill in reverse. What is the most likely equation that makes this graph? The vertex is located at 3, 1. It doesn't quite go up 1 and over 1. It's wider than we would expect. The a value has got to be closer to 0. But let's pretend for a moment that the a value is 1. The equation would then be x minus 3, the opposite of positive 3, and a plus 1 at the end. Three goes in that position and 1 goes in that position. Let's see if we can actually figure out what the a value is. Notice that the parabola goes through the point 6, 7. That means the x value, when it's 6, has a y value of 7. We can substitute that into the original equation. In this case, we'll solve for a. We put 7 for y, solve for a, 6 for x in our substitution. 6 minus 3 is 3, and squared is 9. We take away 1 from both sides and divide by 9. 6 over 9 is 2/3. So the a value is 2/3. Everything in blue is optional and will not be on the test. In our next example, notice where the vertex is. It's at -1, 4. And the a value is -1. It goes down 1 over 1 and down 3 over 1. So y is negative. X plus 1, the opposite of -1, squared plus 4. Each of the forms we've discussed has pros and cons, good things and bad things about them. The good thing about standard form, it's used in science to describe ballistic trajectories. A ballistic trajectory is the path that an object takes when it's thrown or fired through the air. A not so good thing, where's the vertex? It's hard to tell. We have to do some calculation to figure that out. However, with vertex form, we can easily see where the vertex is. It's the values h and k. A not so good thing is, it doesn't match up very well with the science of ballistic trajectory. Ballistic trajectory. So how can we convert forms? Well, the answer is we're going to complete the square. In these examples, we're only going to let the a value be 1. The first thing we do is to rewrite the equation, and we're going to leave a space after the x, and into that space we're going to put the number that completes the square. How do we do that? We take half the b value and square it. In this case, half of 6 is 3, and 3 times 3 is 9. 9 is the number that completes the square. But we have to balance that out. We can't just add 9. And we also don't want to add 9 to the other side of the equation. We want that to stay y equals. So, on the right side of the equation, we subtract 9. Everything written in black there equals 0. So we haven't changed the equation's value. Now the first 3 terms will factor to a perfect square. X plus 3 square. How do we determine it's 3? Because it's half of 6. And 2 minus 9 is -7. And there it is. There's the equation in vertex form. It's easy to see that the vertex is at -3, -7. Now the last example has a negative b value. So we rewrite the equation, we leave a space after x. We're going to put the number that completes the square. It's half of -8 squared. Half of -8 is -4, and -4 squared is 16. 16 is the number that completes the square. We add 16, we also subtract 16 to balance the equation on the right. The first 3 terms will factor to a perfect square. It's x minus 4, or half of -8, and at the end 20 minus 16 is 4. We can very easily see that the vertex is at 4, 4. Let's summarize what we've learned in this lesson. Standard form. The key idea is where's the vertex. The h coordinate can be found using the formula -b over 2a. The k or y coordinate comes from plugging or substituting the h value into the original equation. In vertex form, it's easy to figure out where the vertex is. The vertex is located at hk. Remember, whatever's inside the square with x, we're going to use the opposite number. How do we convert between standard form and vertex form? The answer is we complete the square.